Hello everyone, I hope you're all doing well. In this video, I will be discussing about exception actually, and before that, we will be discussing about different types of errors, syntax errors, logical errors, and runtimes error. And then I will be starting what is exception, and then how can we handle the exception, and finally we'll be discussing about exception arguments. So these are the topics that I will be covering in this video. First, let me discuss about different types of error in Python. So the first type of error, as I have written here, is syntax error. As you can see, syntax error is a type of error where you are not following the exact or correct syntax rule of the language. For example, Python is saying that you must follow indentation, but you're not following. Or for example, if I give a real-time example, for example, Python is saying whenever you want to write in a string must be covered by two quotations. For example, I will say, hello everyone. So this is Python. Python is saying that when it is starting with double quotation, it must end. But if I'm not ending with double quotation, means that I'm not following the correct syntax or the correct rules by Python. So this is nothing but syntax error. If I am having this type of error is called syntax error. So what is my solution to this type of error? Just follow the syntax. So what Python does say, I have to read it, I have to know it, and I have to follow it. If I just put it double quotation at end, then the problem will be resolved. So this is the first type of error. The second type of error is logical error. This type of error, actually in the code, we do not have any error. So the code is going to be executed. When we are executing or when we are running the code, there is no issue with that. But we are not getting the expected output. For example, just see, if I want to print hello everyone 10 times. So what will happen? I have to use either for loop, I have to use while loop. So I will be using while loop. So I will say I is equal to 0. Then I will start from 0. Then I will say while I is less than or equal to. If I write less than 10, because it will 10 times, then I will say print. Then I will say hello everyone. So this is correct. But see, if I want to run this code, the program will be correct. I want to only this to run 10 times. But see, when I'm going to run this, it will run forever. What is the problem? See, it is going to run it multiple times until unless I'm just going to restarting the kernel. So why it's going to happen like this? It is because there is a problem in the logic. There is a problem in the algorithm. So when I'm going to I0, I is equal to 0, I is less than 10. I'm not updating the I. If I wanted to update like this, I plus equal to 1, then this error would not have happened. See, now it's only printing 10 times. So sometimes if I have some error in the logic, or sometimes if I have error in the algorithm, so this type of error is called logical error, and it is the most difficult type of error because finding of this logic that in which part of my logic there is error is difficult. So now if I comment this one, so what will happen? I'm just forgetting to update the I. So it will be changed to infinite loop. So the program will execute. There is no issue with the execution of program, but it will not give the expected output. What is the expected output? I want to print hello everyone 10 times, but it's printing me infinite number of times. So that's not what I was expecting. This type of error is called logical error. And the third type of error is called runtime error. These are the error that will happen at the runtime. So until the runtime or until the execution time, we will not know whether this error will happen or not happen. So let's give an example for this runtime error. So see, if I'm getting a number from the user, you know that, how to get a number from user. We know that we are getting the number from user using input function. So we will say enter a number. And then since this is usually in a string format, I have to change this number to integer. So this is how we are converting a string to integer. And then I want to divide this one. For example, I'm getting a number, and after that I want to divide this number by so I will say my result is equal to I will divide 100 by this number, whatever number the user gave, and then finally I will print the result. I will say the result is, for example, whatever it is. I'll say the result is, and then I will just put it the result here. So this is let us check as how runtime error going to happen. See, it is asking me a number. If I give it 100, so 100 divided by 100 is 1. There is no issue with that. So and next time if I run it, if I give 0, see what will happen? It will have 0 division error. This is called runtime error. Until Unless it is not executed, we will not come to know. So this is called runtime error. Or let's say give another example. If I want to open a file, so I will just use the same concept. If I want to open a file, what will happen? So again, I will say the file name from the user. I will ask the user to provide me the file name. I'll say input. I will say enter the file name. So user will enter a file. I will just open that file, and you know that I need to use file handler is nothing but I will use the open function, and then I will give this file name that the user has given me, and after that I will just print whatever it's inside the file. I will say file handler. So let's run this one. The user is asking me to give a file name. So I have a file called humanity. This is my file name. This is existing. So if I run it, see, I have entered the file name humanity. It is just reading all the content of this file. So this is how we are going to read. Let's suppose I run it again another time. So now I'm giving a file name that doesn't exist. For example, I will say so this file I do not have it. So what will happen? File not found error. This is also called runtime error. Unless it is not going to, whenever it wants to open that file, it knows that this file doesn't exist. So this is called runtime error. So another name for runtime error we have is called exception. Exceptions are nothing but they are the events that occur during execution of program. When you're executing the program, your code doesn't have any problem. There is no issue with your code. But sometimes at the runtime, due to, for example, not existing of a file, for example, due to being the denominator is zero, this type of error will happen. So this is nothing but exception. Runtime error, all nothing but they are called to be exception. So what is our solution to this one? So what should happen, or what should we do so that this should not happen? See, whenever an exception happens, we have two steps. Either we have to handle the exception or our program will terminate. What do you mean by termination of program? See, if I have this code, let me just rewrite it here. This is something that we have already discussed. So the problem is that if I do not handle this exception, what will happen? For example, after printing this one, I will have my remaining code. This is my remaining code. So for example, I will have hundreds of another line of code. So I may have hundreds of lines of code. So now if I run this one, see, if I give the denominator as a zero, what will happen? The program will terminate, and this line of code will not be executed. So what should I do? Then I have to handle the exception. I have to handle this one. So now let's discuss how can I handle the exception. For handling the exception, we have a complete structure. We can use try block, we can use except block, we can use else block, and we can use finally block. I will give a broad explanation of all of them. So where do we use try block? Whenever we know that this part of code will raise an exception, will cause an exception, we will put that code inside try block. And whenever we have a solution for that one, we will put our solution inside except block. And what about else and finally? They are optional. Either you can use it or you cannot use it. There is no issue. Else, we will write the code inside else. If exception does not occur, this will be executed. So the codes which I'm writing inside else will be executed if and only if exception does not occur. If exception is occurring, else will not be executed. So it is nothing but it's against except. If exception happens, then except block will be executed, but else will not be executed. If exception does not occur, then except will not be executed and else will be executed. And finally, this is a block of code where it must be executed. So sometimes we have a part of code that we are saying either exception occurs or does not occur, but this part of code must be executed. So that part of code we will write inside finally block. So now let's go and apply this one in this example. How can we do it? We know that whenever we are entering a zero as a denominator, here it's giving that at line number 2 this error occurs. Since we are going to divide at line number 2, so this is the line number which causing the exception. So we have to write this line inside try block. So we will write try, and inside try block we will write this part of code. Control X. I will just see this one, and then I have to handle this exception. Handling means what? If this denominator is going to be 0, what is my solution? So I will say except I will just copy paste this error from here, zero division error, except if zero division error is happening, then what should you do? I will just say print the denominator must not be 0. So that's it. And then after that, I can write my else also. So I will say if this is the denominator is not 0, so we will get the result. Inside else, I will just print the result. I'll say print the result is, and then I will just say result. And final block, I just told you that final block is it's optional. You can write it, or if you do not write also, there is no issue. But the code which is inside this always will be executed. So now let's go to run and check what is the difference of now that I have handled this exception with my previous code. See, now if I am giving to give it, for example, 100, see now exception is not occurring. So what will happen? It's just going to take 100 here. It is going to just divide 100 by 100. It's going to get result as a 1. So no exception. So when no exception is happening, this will not be executed. So here else will be executed. It will print the result as 1, and then this line of code will be executed, and the remaining code will be executed. Let's see. Yeah, it's the same thing. It is just it's saying me the result is 1, and then code with that always will be executed. So I have printed the result 2 times, so it's again printing me the result. So let's remove it from here. Now let's give it 0. So if exception happens, what will occur? If exception is happening, if this number is 0, so exception will occur. So this except will be responsible for handling the exception. So this line of code will be executed, but this line of code will not be executed, since if exception is happening, we do not have any result. So this will not be executed. This line of code will be executed, and goodness is this, that the remaining code will be executed. That's the beauty of exception handling. See, if I give the denominator is 0, see, the denominator must not be 0. This is the code which is inside finally. Means this code will be executed either exception occur or does not occur, and this is our remaining code. So what is the advantage of exception handling? See, previously when I was not handling the exception, if denominator was 0, this remaining line of code was not executed. So now this how I handle it, it's not mattering. It matters that when I am doing exception handling, if the denominator is 0, my remaining code will be executed. That's the beauty of exception handling. And see, we have another thing called as a exception arguments. So sometimes, for example, now let's go and give an exception handling for our previous example, which was nothing but file not found there. For example, if I want to handle this exception, what will I be doing? So let's discuss this one. I will just put it, yes. See, this line of code, if I go to file not found error, this line of code is going to cause me exception. So that's why I will write this line of code inside try block. So that's why I see there's a try, and then I'm going to accept. Except means for what you want solution. I will say if there is a file not found error, then this is my solution. So what will happen? I'm saying that if a person is giving a file that does not exist, you must open this file called as a default. I have a default file. So I will say, ask the user file name. If the file name is available, open that file name. But if there is exception, means that file does not exist. The file is deleted. So I have a default file. This is my solution to exception handling. And then inside else block, I will say if you are able to, I can write it without else block also, so there is no need for else block and finally block here. So they are optional. Sometimes you can use them, sometimes we will not be using them. So for example, first time I will giving a file called humanity. See, it will open that file. Next time, if I'm giving a file that does not exist, for example, like this. Still it's opening the file called default. So this is called exception handling. The beauty of exception handling is this, that it will not crash the program. So if this error is happening, this is my solution. And lastly, let us go for the exception arguments. Exception arguments, sometimes see, just now we were discussing two types of exception. One was zero division error, when denominator is zero. One was file not found error. So we have different types of exception. But sometimes, if you're forgetting what type of exception will come, for example, if I'm just copy pasting this code and only this part of the code, and if I do not know the name of exception, so I do not know zero division error, I do not know the name of class, so I can write exceptions. So this is the folder of all the exception. So I can write here, and I will write as, I can read as E. So what will happen, and now I will print E. Now it will give me what type of exception will happen. So I can write zero division error also. There is no issue. But sometimes, since I want to more generalize it, at any type of exception that comes, this is my solution. Just print the exception. See, for example, if I give zero, so zero division error. Now, zero division error is stored inside E. This is called exception argument. So we can give exception argument. Here I can give zero division error also. There is no issue with that. So now if I run it, the same thing will happen. So it means that if you want to print this one, and later on you will say inside the program, after this zero division error will be called as a E. I'm printing E. It's just saying that this error or this exception has occurred. If you want to specialize it, you will say zero division error. Zero division error will not be able to catch the file not found error. But if there is exception, it doesn't matter. If file not found error is happening, it will handle it. If index error is happening, it will handle. If value error is happening, it will handle. Any type of exception that will happen, it will handle. This was the end of the video. Thanks for watching.